Hi. No. Hi. Sorry. Set up. So this is the class for the micro theory, the graduate level. We supposed to be the ELD, but I guess the room is too small. I mean, turned out that I need more people that can incorporate that small room, so we changed to this room because all the rooms are booked. The case that we are able to find a better room, then we switch to, but I'm sorry that you learn this computer lab, which for theory class, which is super needed. We don't really need any computer, uh, but uh, but anyway, let me introduce myself. I'm Chiu, so I I did my undergraduate here in B school, and then I go to get a master's degree in econ department, and then I go to US to study to get my PhD degree. After that, I go to Singapore and taught there for 7 years, and come back, and then I teach this class among others. So my research is on microeconomic theory. So this is basically my field of research. Of course, this field is super big, so I don't claim expert on this, but I can fairly say that I know better than this compared to what I know. So that. So I guess this class, many of you are from B school, and you need some of them for your research. If you do theory or even you do empirics, you also need them because understand what people are doing, give you some idea how to think about your regressions, right? Because understanding the model is a good way to understand how to write down your identification, how your causal inference, and how things being done wrong. And these days are very demanding where you have to at least know how to connect your empirical research to models. So that would be the main purpose. As you can see, the way we cover is very ambitious. And usually this class in econ department will be divided into 2 semesters. The first semester being the first part called individual decision theory, right? That will be the first part. Usually you study for semester, which we try to cover in 3 to 4 classes. And then we'll study game theory, which will be the main thing that will be the most useful thing. I mean, for marketing student, finance or accounting or management, because people are strategic or people interact, right? That's the B school, right? It's how to deal with others, right? Because the first part, individual decision is just like people just face the environment and do decisions, right? Taking the environment exogenous, right? What you do is going to change the environment, right? Just act based on what is given to you. But for game theory, right? I mean, a proper name would be called the interactive decision theory. Is the idea that what you should do depend on what other people will be doing, right? In that case, that's why we need game theory, and that is basically business world, right? Because you work with others, right? For business, right? So that was the thing. And the last part, if you have time, we'll cover relatively new is how to apply game theory to incorporate contract theory, option bargaining, market design. These are relatively new topics. I'm not sure if the time. So used to be the case, even we can only cover the first 2 parts. If we're lucky, then we can cover the third part. This year, of course, I try to speed up a little bit. So I will just cover the way I cover it. Just I will do skip the technicality, focus on the main message, and focus on the main thing. I would put the slide that is a little bit more tedious as a reference. I will probably not cover it. You can read it for your try to speed up a little bit. So probably the learning outcome. Hopefully after this class, you will have some idea of what microtheory is about, and how it's being applied. And hopefully you can use the skills that, especially game theory, in writing your model. At least some basic model you can put in appendix when you write the regression. And the tools we are using is standard calculus. I assume that you would have basic knowledge of calculus. If not, that should be fine, but I think you can take it up fairly quickly. And the last part is try to apply the modeling in solving a business decision that would hope you to achieve it through a project. Okay. So in our class, the assessment scheme is, I guess many of you are Ph.D. student. I think assessment scheme doesn't mean anything anyway, but we'll give grades at the end. But the first part is assignment, trying to make it work on some problem. And the assignment will be graded by 10 only. So I just try to look at whether you do it right or do it seriously, then you probably get almost all the credit. I mean, 90 or 95, and the remaining 5 to 10% will be based on how well you do. So basically, if you do it, then shouldn't be something that bother you too much. Because I know as a Ph.D. student, you would have a lot of things to do. I mean, doing the assignment for this class would be probably the last thing to do, right? I mean, you probably have many things, important things to do. So I just want you to attend it. You don't have to worry too much about it. I encourage you to talk to others. Talk to your classmates when you do the homework. There's no problem. Of course, you submit your own version, but I actually encourage you to do it. Even in the econ department, they actually encourage students to talk to each other. Do that side. What independent work I want to do is the project. Actually, I suggest you to take the opportunity for this class to write some toy model, or at least you can review the toy model with the literature, right? Or the easiest thing you can imagine is to pick up empirical projects. If you want to, if you're not going to become a theorist, pick up empirical paper, which if they have the modeling section, then it's good. Then you can try to understand and try to modify it. If not, you can try to do a model to explain what's going on there. Hopefully it'll be good. But of course, in the past, there have been people who hate doing any empirical, don't like any about theory. Then you may just do literature review. You can review what model has been done and do a short literature review. Also, okay, just make you to work on some theory. Of course, don't review empirical work. I mean, otherwise, defeat the purpose of what we do. It's just theory related. It's fine. I don't have any super restriction on that. Test is just with your last class. Open book, everything there. Then you can bring anything in. Just last class. Is that okay? I mean, I hope that is something. I mean, don't make too much burden on you. So at the end of the semester, we have course and teaching evaluation. That's a RAS standard. Okay, and regular scripted standard. So just give you some idea what we will cover. In the first 4 classes, we'll cover, as we said, individual decision making with a very standard microeconomic theory. The first one is the consumer look at the preference, utility demand, right? Because we know traditional consumer, you will learn from economics, is a downward sloping demand curve. It's like this one. And we will try to give you the foundation from economist perspective, how we can derive this downward sloping demand. Give some idea of some preference or choice set. If you're from marketing or psychology, that would be something that we say, like how people make decisions. And the second class was the production. We will use the very traditional view of production. We just consider the profit maximizing competitive firm or monopoly. So we just make our life really easy. Make the firms a black box. Those who do management or do marketing or finance or corporate finance really hate what we do. But that is the worst starting point to get the upper stock in supply curve. That is what we learned from the microeconomics, just across the case and the classical Marshallian course. And then we try to look at the market equilibrium by looking at demand supply. That is a very classical one. And we talk a little bit about general equilibrium, some welfare theory. And for those who study finance, that would be the main thing they're looking at as surprising, right? They look at why everything dies, then the financial market also dies, right? Why we need so much different kind of financial instrument, right? Because of there's some ease of market inconvenience, and that's why we trade different kind of bonds, warrant and option, and so on and so forth. That's all. That, but we don't really touch in detail, but as you learn as a class, we just give some idea why market work is called the welfare theorem. And of course, welfare theorem doesn't work always, right? That's why the financial crisis happened and everyone suffered, right? I mean, if that's the case, and then macro has no place in the world. Macroeconomics is there because of welfare theorem doesn't work. If you look at why the recession, why there's stuff. Another day we look at choice under uncertainty, where people make decisions in an uncertain world, right? If you look at asset pricing, it's a way, right? You do marketing also the same, right? That's how you make decision when things is not clear yet, and there's something is going to realize in the future. Another day we look at game theory. I think this is how I make my money. Right? So I do game theory. I do IO, and this is the thing. And classically, we are looking at game theory when usually now people mean game theory, they mean the non-profit game theory, which means that the standard 4 different types of games, right? Probably you learn the Nash equilibrium. It's a game that where people move at the same time, everyone knows how the games and they play, right? It's a game of chess. It's a very common game, right? Rock, paper, and scissors, and these are the standard games that you play. And believe it or not, although this is the most simplest game, and this is the game that you will apply in practice most of the time. The next one is to extend it to dynamic, right? Still remain company formation. And this is also the game that we often see in marketing, finance as well, right? Is we rely on barrel induction, or with the game, the fourth theorem. These are the main key things you need to learn, right? And there's usually the multi-stage trading, right? In the first stage, we do one, and second stage, we do one, and the first stage, we do one. Okay, so this is very common. And topic 7 and 8 will be very similar, but we have incomplete information, right? There's actually the second game on immersion is going to be related to the contract theory, right? And mechanism design problems. And the dynamic games on confirmation that will relate to signaling games, related to how traders, right? The dynamic market, right? Option or bargaining, all these important applications is all here. That being said, this we don't cover is called corporate game theory, about the core nucleus, those particular concepts, which is on mass bargaining or those important application is not being covered. I mean, it's also not covered in standard econ department, but if we have time, we'll try to look at more in part C. We look at contract theory, look at design, look at how some IO model. I mean, if you are from operation management, then you also do this kind of model. With the marketing, also this kind of problem, supply chain problem. These are ways that. And if you are from finance, marketing, corporate finance, right, you have a lot of targeting problem. You would probably decide context and there's a matching issue there if you are talking about management information system, that is something that you'll be working on. This year, if we have time, I try to talk about behavioral experimental economics, which become increasingly important. But I'm not sure of time, but I will prepare slides. In case I don't have enough time, I will prepare it. I hope this is very ambitious, but at least I think I will cover A and B, and maybe some part of C and D. Just a plan. We always underestimate how hard things go. Whenever in the future you do your project, you're saying you expect you can finish it in 3 months, and usually you can half a year. Right? You expect something can be done in 1 year, probably take 7 years. We're standard. You run out of time. The textbook we're using is rather standard, right? And the first one is muscular wisdom Greek. It's the classic Bible for microeconomic theory at the graduate level. The one that we use for this class is this one, M.Phil and Randy, which I think is a good book to read. It's like master PhD level, but I think for business school application, I think this book. I don't think you would actually need the muscular wisdom Greek. To be honest, I never use it. I bought it, but I never actually use it for the class. I mean, my experience tell me that reading that book is not going to help you learn because it's written the way that if you're math oriented, it's not going to understand it. So I recommend you, even if you really want to go to the hardcore, I recommend you read this book first to get understanding what's going on, and then go to that book and you will understand. This is much easier to read. And of course, if you still think that this book is a little bit more complicated, you can go to the very classical graduate level variant. That would be the thing that you can go for, because that is a slight upgrade from the intermediate version of the variant. And if you want some new books, that would also serve the purpose of class. You can read the Rubinstein lecture notes. This used in the NYU, I think, where he taught. And this book is a little bit easier to read. It's much shorter. It's lecture notes. The good thing about this book is it talks about things in a way from new perspective, which when you read it, then it's very different from the first people. We're going to first do the very classical way to understand the subject matter. But Rubinstein trying to challenge the traditional way of thinking about how microeconomic being done. So if you want to see another perspective, I recommend you it's also very short. And another one is game theory. I recommend you to do the difference. It's a very classical book that you can read and try to solve the problem in that book and help you to understand how to apply. Yes, a lot of applications, although a little bit old, but I think game theory is old for anything. So I think that would be fine. There's nothing to work about. So there are many suggest reference. So if you want to do theory, I highly recommend this very short piece by Warian, how to do a econ model in a spare time, which he described how he write an AR article, a model of sales. He tried to explain that you go to buy TV in 80s, and you look at the price of the stock is very different every time you visit, and I try to understand why it's the case. And that's why he built a model saying that firms are doing mixed strategy. They randomize the price up high or low at different point of time. And Why is the case? Why not a fixed price? The reason is being that some shoppers don't want to shop, they're loyal to you, right? You can always charge high price to them, but you cannot fix single price. You do the random price so that people may still go to your shop if their price aware. In that case, that's how he built the model to explain that why there's price distortion. If you do marketing, there will be some model that you may usually have read. And the further reference, I think that I don't think that I need to go to further. Just telling you what's there, and there's some methodology. The book that I want to recommend you to read, I think that is the probably a little bit more important. We look at writing, because I think none of you is using English as your first language, and writing in academic setting is very different. I mean, of course, ChatGPT can help you writing, but they didn't write in your way in the technical or in the professional way. I mean, if you write it, ask them to write a literature review, but ask them to write a model is usually not well written. So I do recommend you the third one, William Thompson. He tell you how to write properly in terms of theory. Of course, here's another book. The whole book tells you how to write, but this is something that if you want to write theory, or at least the modeling section of the model, you should read this short article that tells you how you should write proposition, how you write definition, how you write the model. This I will recommend. And how to structure your paper or paragraph is very important. I do recommend you read the first book. This first book tells you how you write an excellent article, right? And tell you how to write your structure. It's a called the inversion method. You write things in a order that different from you write a novel. Exactly reverse order. When a novel, you read to the end, you know what's going on, right? And they tell you that the method is called big idea. The bottom line first tell you that you should write in the way that your conclusion goes first. Just like the business document, summary, executive summary. You write the thing first and then build things gradually. We do recommend you to read that book. And others, I think that's last one I also recommend as well. Probably this book will be great if you have read for the first year, is to understand what's going on in research, how to do research, what your expectation from the advisor, expectation from writing your article, reference report, conference, and so on. Although I'm not your advisor or your related to your graduate director, but this is a book I recommend to all my students. That would be this book. And since we have most of you are from business school, so this try to convince you that our course will be useful, because they tell you that why we need game theory, why we need microeconomic theory, and are those. You don't have to read those, but just telling you that, I mean, there have been a lot of articles being written to explain why you need that. The rest is I don't think I need anything. And this is the schedule. I think that I already explained to you. I mean, the first 4 class is part 1, and the next 4 with part 2, and then hopefully I can cover the part 3 as well. But we don't want to rush, right? Because if you need me to slow down, I slow down. Yeah, I'll keep asking you whether I go too far, because there's no point in rushing. I don't get the message pass by, right? because now it's easy to search information online, right? And then that's why if I don't cover that part, you can learn about yourself, right? So as long as I cover the core thing, right? Game theory and the decision theory, then that will be fine. The rest will be just if I apply this, you learn it when you actually need it, right? This part, I guess, we don't really need that much. Just because we're writing papers, for the projects, right? Or literature review, from there you don't do copy and paste, right? So try to make sure that you do the checking when you're starting your project. That would be. Okay. Is there any question related to the course, the whole course? So I think our exam will be last class, and the project also be on the last day. Maybe at the time when go to the very last few class, we can help you with the extension. But otherwise, the expectation is on the last day. Something probably you ask me how, but probably I'll upload a little bit more about the project, but I would expect it like 10 to 15 pages of the project. I will have uploaded later. But otherwise, any question about this course? No. Okay. Yes. Oh. Oh, I'm sorry. Yeah. Thank you. So the book I recommend this or writing. Oh, writing. So academic writing, I think that is the most important part of your paper. Okay. I mean, of course, the core content is important, but if you don't know how to write a paper, then no matter how good your theorem is, it's not going to help. Okay. So after many years, I think I wrote one book. There are many books, but I do recommend you read the very first book. Okay. The very first book actually tells you how you structure your paper, how you write your introduction. Okay. Maybe I give you something to ask, I can give you some idea what he's talking about. Okay. So the way that you should write a paper is following what we call the inversion method. The inversion method means that it's like triangle. Okay. You start from the very broad idea of what you are going to cover, right? Maybe looking at a particular literature, particular business environment, right? And then you narrow down to what you're going to say, right? In particular case, for example, we're looking at the problem of, I don't know, maybe I talk about the sales problem with the variance set, right? So the way you would start is looking at the phenomenon where the price you observe going to their everyday phenomenon, right? And then so and so forth go down to build up a model to explain that. You can read this book in detail, and then they tell you how to structure the topic sentence, right? They will say each paragraph should have only one idea, right? Preferably your introduction. If I take the first sentence of each paragraph, I only read the first sentence, you already get what we want to say. Okay. And everything in the same paragraph is supported in the topic sentence. Okay. And then you should make clear to tell a story. Instead of saying, when you write literature review, you shouldn't say X do this, Y do this, Z do that. Right? Instead you say X, how X do it related to your work. Right? How Y do this related to your work. Right? When you say, when you try to explain your empirical result, right? You try to build a story to say how this result related to your main idea of the language. Right? You say the beta is 0.1 or beta is certain value, right? And you have to explain what is the economic significance why care about it, right? Just don't briefly give us bunch of facts, we don't care, right? I mean, of course, there's a lot of things in this book. It's very small book. It's not expensive. I think you can buy it. That's a good book. And of course, there are many books like how you should write. I mean, these two, but closely is a very good way to tell you. There's some way to improve the wording, right? For example, you should never use respectively. Say A and B to do C and D respectively, right? Usually respectively is redundant. Okay. And try to use active voice, not passive voice, whenever possible, right? And then it's good to say active voice. It means that we define this problem, or we look at this problem, rather than say this problem exists. This kind of passive voice. There's many things that say, or other advice they give is like try not to use different adverb, different word to do the same thing, right? Mean for your non-professional writing, people would appreciate different adjective, adverb, or different words to do the same thing. For theory, you should, if you use the same term, in your model, use agent throw away. If you use firm, don't use company. Use manager, don't write the CEO, don't write the thing. Don't write the owner, right? If you use one term, say throughout. Okay, so that would be the idea. I mean, and yeah. So I think these all at least is I have read already. So I mean, there are many more, but I think that would be good to go. And then the last one will be also good is because they tell you how to write empirical paper. There's some part of it telling you how to structure your paper, how to write empirical part, how to write a regression, and how to structure your paper. That's very important. So that's why if you theory, you read the Tom sample. If you do empirical, you should do this as well, because this guy I think is a research head for some policy world, and that's why he knows how to write a empirical work. I think I'm not sure if I answered your question. Feel free to ask. I mean, it's a good example of we have small class, so please feel free to ask. Otherwise, I don't know if I convey the message. Any further questions before we discuss? So there are two ways. Either email me or email you anything. The second is if you form a register, you should have the first that one. If not, then again, or you can ask a friend to send you. I don't have the others. Just email me again, but all the slides are in there. I don't have to trust them. Any more issues, concern that I can address before we start? Yes. No determination, just one single final at the end semester, open book. Okay. Because I know everyone's very busy, right? So I don't want to make you suffer, right? For the that, but to learn, I mean, you should do the assignment. Because the assignment is very short. I mean, so 1 or 2 questions on which topic, and that's it. Of course, to master you should do more, but I just make a minimum requirement, and it is try to be minimum. If you want to learn more, actually, project is something I want you to work on for. That makes you a little bit understand how to write. Because when you look at the model, standard model being written is very easy. But you try to write a model, even write extension of it, try to change it, then you learn how to write. Only by actual writing you learn how to write. Even copying other existing paper style, how you lay out the thing. Already copying the way they write is already really precise. Same for empirical project, right? If you try to copy how the main data run the regression, how you lay out the model, how you lay out the data, how you write the robustness checking, how to write those things, it's already. So I hope you learn from writing a model or literature review that would be effective. Because solving the model, I mean, now it's not very impressive, right? Everyone knows how to solve the model. So sooner or later, AI will solve everything. So the main thing is to how to in the model, right? Is how to design the right model and to solve it. Right? The solving part is not it's important, but it's a skill that is not suitable. Right? One thing that's most value added is how to think of the right model to answer the right question. Or if you have empirical part and then you think about why your model would get that way. Right? Because right, the proper way to do empirical project, right? I mean, I understand this. You would have to do hypothesis, right? Explain that, right? Of course, if the thing goes the way you want, you don't need a model, right? But if the empirical part goes against what you think, then you need a model, right? Otherwise, what I mean, people would question, right? You should have a structural model to kind of be useful, more or less like that. But I don't. Any question before we proceed? Feel free to talk because I'm pretty sure that yes.
What resource can we refer to in the slide?
Whatever you can bring. Now the only concern I have is when we have the iPad or computer is there, maybe some communication that is a little bit concerning. And if someone complains, then we have to do it. So the current practice for me to do open book is you can bring whatever except the content. So you can print whatever, bring whatever, and your open book means you can't share your thing with your classmates. You bring your own, bring anything classmates. This is what I think. But if you think about the way, there's no way you can contact each other. I can. That's why I don't care. The thing is like if someone complains, then if someone say I don't get a good grade, then okay, that's complaint. Then right when they complain, then it's very difficult, and then you take all the grade. Right? So to avoid this problem, just go and you can bring whatever material you bring out. But don't worry, I think this class things are very straightforward. I don't think there will be any issue for you since you admitted to critical that is not like that. What we cover is not something very complicated. Any further question before we proceed? Feel free to ask yourself. We'll start right away after the break. No? If not, although we are 3 minutes early, then maybe let me start that's what we do. Is we have some ice breaking thing using the UU reply. I'll keep doing this indeed for the anomalous thing. Is the question? Oh no, not this one. No, just the standard one, I guess. The break one. Yeah, I think this is a good one. Let's do that one. The break. That's my one. Oh, go to the report page. Oh yeah, this is the one. Oh, it's here. Oh, yeah, this one. So this usually I do. Let's try to do a test. During the breaks, I just want around to talk to you, discuss the question. Also, you can leave a comment on this, and then I can try to do back because although you're a PhD student, then many of your first years do resign, saying anything, but you can just leave there. It's anonymous, not taking an attendance because it's not recording it. So just if you want, you can take a draw clock and just write down whatever you think, then you try to answer that. If nothing to, if you're not going to say, it's okay. It's not to get handed. So at the break of 15 minutes, we'll come back at 1:30. In the meantime, we walk around. Feel free to leave the room if you take a break. Remember, non-smoking camera, so we can leave the smoking. Get away from that. 小飞机，然后一共甚至跑到的一个，然后我分它这个。但是我们没有找，不好意思，那个跟你3万就是，对我们没有协调，回报你们我都可以报。我太发了，跟我说一下这个我是定的。好好讲，待会儿说，对不起。哦，有种的，对的。OK，我也知道，是。好，好，看到这个在都是。那个最近主要怎么办一点？看你的时态如何比赛。我们如果看那个地，不要很在，过了还是比较记得。有太太，有他的这个现在这个有不看看你，那个就好，再好，再好的对不对？那个都是这个，那不是有来这地理的问题。还有都行，他就是刚刚还没有说把那个看啊，他的新加坡。不要他发了。很大的一个类型啊，也有可能不是他有在做那些运动现在都在去做这个，但是要反正按照怎么变这个样子，还是我们的 graduate student 按照差不多。 对啊，我觉得你们俩看点的一个看点，这样看点本身那个行业的超脱本身作为看点，大家都有吧？这哪看进去？看进去。我们这边导这比我读书的时候，我老师说你也没有说他。我应该不应该这种啊，大会的老师多大？对，现在好像要不然就被这个。好分，这个行业都很分的。OK， 那边做吧。Hi. Hi. Let's get back. It's good to talk to you. Some of you during the break. So just see if anything to say. No, yeah, that's good. Yeah, if you make correct, that's good. I think just a test of how we're doing. Now that is a very good example of microeconomics. Okay, is everyone we do not reach agreement on what's weather now. I mean, some people think it's rainy, so you can see people saying sunny. I think it's talking about objective facts of what's going on, and there's ambiguity about the weather, right? Because I don't talk about whether it's outside, right? It's the weather you think, right? So some people think it's rainy because I think it's he or she is stuck in this classroom to take microeconomic theory, which he or she doesn't like. So he feels rainy, which I understand. So that means that, right? This is a good example of why we have to study consumer, because everyone have different view, even the same objective facts. Depends on how you interpret. Yeah, there's nothing here. That's good. So seems like someone think I'm too fast. I try to figure that out. Yeah, so far it's okay. Okay, so that's good. I think it's a good idea that you know how to operate the system. We'll do that when we have second break again. Then you can tell me how fast or how slow we're doing. Okay. So let's get started about consumer. Okay. There's no clicker here. Okay, that's fine. So for consumer, what we're trying to do is to tell you the basic model, how people make decisions. And we use it, the use case is how the consumer interact with the market. Okay. The consumer is small enough, it doesn't change the market. So that's why it's a decision problem, right? What he do or what he or she doing is not going to change the market price, not going to change any market parameter here. The market parameter is taken as exogenous. So that is the way
we're looking at how people make decisions, and you can extend this to any other situation, right? Although we talk about a consumer facing the market, right? Is facing the market, is facing how much he has and what's available there, right? So there's a feasibility constraint is how much he has, right? And then what he's choosing is choosing the best thing he can do given how much money he has, right? It's a resource allocation problem in general, right? Economics, right, in a broad sense, is resource allocation, right? If there's no resource allocation, no constraint, there's no economics, right? If you can do what you want without constraint, you can do the best. That's the done, right? There's no economics because that is what about. And then we illustrate that by doing consumer facing the market. You can imagine in other cases like a husband is trying to allocate his time across his wife, his secret lover, his son and daughter, or whatever, right? That is the thing, right? Or how to spend his time with his boss, his colleague, right? Or you go to a dinner, how big the stomach is fixed, right? How you allocate among food, drinks, alcohol, cigarette, or whatever, right? So that would be the same idea, right? Just like you're given resources, allocate. But we use market example because everyone buys something every day, right? Or you're thinking about you attend this class, you have the homework to do, a project to do, right? You do, and then also other class as well. You decide how to spend your time, right? And you can imagine that you cannot affect the environment, right? You just take an environment exogenous. Okay? This is what we're looking at. So we start with the preference and utility. That is the basic way economists think how people behave, right? If you are doing behavioral economics or psychology, okay, if you do psychology, they're slightly different, little bit furthermore, but the preference is taken as given, okay? How preference form is psychology, okay? But we start from preference. We don't go a little bit backward. We start with preference. By preference, it means people have ranking over alternatives. You like this option over the other, okay? And utility is to give number to different alternatives. The higher the number, the better, okay? And we assume people would do the utility maximization, right? You can rank alternatives from best to worst, with best give higher number, worst give the lowest number. The number are called utilities. And utility maximization means that you're trying to maximize your choice given the budget constraint, okay? And that means that we're doing constraint maximization. By assuming everything is continuous and defensible, you just use the standard calculus method to do it. And by doing so, we derive the called the Marshallian demand. It's a downsloping demand. That is the main goal of this class. Okay? But if you learn math, right, or linear programming, right, you can invert this problem to cost minimization problem. It's a dual problem, right? You can, given the budget, maximize utility, right? Or you can, given your utility, find the minimum expenditure to achieve it, the standard linear programming approach. Okay? Either you maximize something, subject to constraint, or you minimize something, subject to constraint, the same thing. So you give the dual approach to this problem. And probably you ask why we have to do that, right? Because it's a regression reason, right? Because this is very natural, but what we observe in the real world is how people spend, right? This is what you observe, right? You observe the prices, observe how much they spend, right? You never observe utility, right? So that's why by looking at this empirical problem, you can back out, okay? And of course, how to back out is a deep theory there, but there's a way to come here to here. Okay, so that is the goal. Okay, we understand the downsloping demand curve. Okay, and look at the and then that will collect to the expenditure function. Of course, I'll give more detail, but this is the idea what we're trying to cover. And in the meantime, there's something also very important, it's called indirect utility, right? Because that is usually how we work when we do IO model or do empirics, right? We don't start with utility directly, right? Because utility means what? Is we are given the bundle, right? Different bundle give us different alternatives, give us utility, right? But indirect utility is not taking the bundle, but taking the environment, look at prices and the budget, okay? Look at the exogenous variable, the environment give us what utility, okay? Taking the maximization at the background. And why we care about this? Because this is something that we can assume directly and we write the apply model, okay? And that gives you how and why we can start from this. In a lot of IO model, we just directly start with this. We don't go from this one, we go to here. Okay? So this gives you the foundation, what we're doing in IO, in operation management, in accounting, or in finance. Okay? So this gives you the idea. And the last part is to give the foundation, what we call consumer surplus, and which is ad hoc when you learn it in the intermediate micro. And we give the idea, the consumer surplus is closely related to utility. It's measuring how people happiness, okay, how well you're doing. And why we care about consumer surplus, okay? One is being that there's a lot of model that directly model consumer surplus directly, right? Because as a firm, later you will see, right? You want people buy something, right? And then you want to maximize consumer surplus, right? There are a lot of model, but because you don't want to go into very big detail about competition, and then you can assume that firms are competing to maximize their consumer surplus, okay? And that gives you a foundation. And also we talk about antitrust or competition regulation, and there's the consumer surplus criteria, okay? And then we give you the idea why consumer surplus is the right measure, right? Because consumer surplus is basically coming from the downward sloping Marshallian demand, okay? So I give the idea. I don't know, I'm talking too much technical jargon because I don't know what your background is, but I hope it's okay. But I will define everything clearly one by one, but just give you an idea what we're doing for this class. I hope to finish all of them, but usually too optimistic. Probably I will take 2 weeks to finish this most important chapter. So let's start with some definition. This is a very standard theory class, right? So all the theory class will do the same thing. We define the environment in notation, okay? Some definition, and some results, and some proof, okay? For this class, we'll be B-School, so we will only talk about very little proof, 1 or 2 proof to give the idea of how proof being done, okay? In very loose manner. We're not doing a direct proof. But in terms of notation, we try to be as rigorous as possible, because that's how paper being written. And you need to understand how to read papers. Okay. So we started the world with commodity, okay? Because we're talking consumer consume stuff. So commodity is stuff to consume. Can be food, can be leisure, can be time, can be anything. So it can include anything, okay? And we consider in our current model, we have finite number of commodity, and infinite will be very complicated. We just finite number of commodity. I mean, it's not too much a stretch because in the world, we only finite number of stuff, right? Quantity can be infinite, but stuff can be finite. It's not too much a problem, okay? And the next assumption, a little bit crucial, is we assume commodity is infinite divisible, okay? Which may or may not ring the alarm for you, right? You can have 1 potato, 1 apple, 2 apple, 3 apple, 4 apple. You can also cut the apple in half, okay? So it's okay. Sometimes divisibility is an issue and can change a lot, okay? But I think for our purpose, it doesn't really matter, okay? And since there n commodity, we will describe a real number, a positive number. Okay, this means non-negative number. Okay, as the quantity that about a commodity. Okay, by writing this, we are thinking about each commodity are the same, right? An apple is an apple. Two apples, the two apples the same. Okay, if you have different quality of apple, then it means another commodity. So quality is can be there. Okay, so it's not there, but you can imagine if you put in same category, right? Then it must be same quality here. Okay, and in terms of notation, you can see the R plus or R bigger than is the same thing. So you can depend on books you read. Okay, as I said, infinite divisibility is a group approximation, and things can change. Okay, and for those people who do empirics, this is also important, right? When you don't run regression, the y is a continuous, it's one thing. When y is discrete, another thing, right? You have current regression, right? So the same for economics, right? There's a lot of things how the measurement problem is whether you can allow discrete integer or continuous can be very different. Okay, but in your class, we keep everything very simple. So everything is continuous and very nicely done. Okay. Now, so we will call a vector x, and for vector we'll use the whole ones. For x, it's a list of numbers, a vector. Okay, it's an n vector. That have a quantity of different commodities. And x is 1, 2, 3 means it's 1 unit of 1, 2, 2, 3, and 3. Okay. So we are looking at different type of consumption bundle that the consumer would choose. Okay. And in these two world, we will draw a picture, right? And although this class is about theory, it's very good to remember you should write good pictures. When you write a good theory paper, pictures can help a lot, at least for presentation. Here you have a two-dimensional diagram, right? With a two good world, a 0.32 represent 3 units of good 1 and 2 the good. Okay. So I hope this is clear. You learn this in the grade. But as I said, I assume no prior knowledge, so I start from the very beginning. Hope that you don't feel bad. I start too easy. So here is what we have consumption set. Okay, is what is available there. Okay. And in general, okay, what you can consume is a subset of the positive project, right? In the case of the diagram here, in the case of here, right? It means this all area, unbounded area, right? From 0 to infinity, from 0 to infinity, any quantity can be there, right? But usually we would sometimes we focus on some subset of it. Why? Because there's some feasibility constraint. Okay. Say what you can have, right? It's limited by what's available in the world, right? There is some constraint. And but in our class, we focus on the simple. Okay? But when you apply to your work, then maybe this constraint will be important. Right? Maybe what's available there in the real world, that will be an important constraint. But in our class, we just focus on the simplest one. Okay. So why I have to emphasize on definition or something behind, it is how you should write a model and how you write new models. Okay. You understand how they describe the model, then you give you an idea what can be done. Okay. Or what the limits of the model and you can extend, right? Because in this case, right, there are papers that try to improve the macro model. Yeah, the economy is working. And recently there's a paper talking about what we call the I think B.B.A. in science or nature, talking about
sustainability constraint, right? Whether the growth will be constrained by the global warming, the climate, or the earth constraint. Okay? And then you can say the model is converted. But then you can see by imposing different constraints on what people can do, depending on how you impose it, can lead to another thing. So be very careful how you define those. Okay? And I hope by going things slowly, then you know what assumption behind the standard model. Okay. And we start the environment already. Okay. So most consumer we choose a bundle from that. But how consumer
Assumption is what we call a preference.
And preference, if you look at the textbook, they will define as what we call binary relation. And then you ask, what is binary relation? Binary relation is basically I keep a bundle, set a bundle, okay? So product set by itself, okay? And I'm looking at how different bundle are related, okay, with some relation. Okay? If X and Y are related in this way, okay, is in this particular set, then that is we write X bigger than Y. Okay, so to repeat, I think this is a little bit more tricky because it took me quite a while to understand what's going on. Okay. So binary relation is comparing to is how different bundles same set relate. And formally, how you represent it is the product set of itself. Okay. If they're related in this way, this ordered pair belong to this subset. Containing, okay, this is a little bit definition maybe still a puzzle to you, but let me define it in a by example. Okay. So let's make our life easy. We just only have lead and one commodity there, right? Or just number. Okay. When we have equal sign is a binary relation, right? When the same, then they belong to it. So that means one is included in the equal set, and 1, 2, or 2 is not. Okay. So you can represent the binary relation is a diagonal line on the graph. Right? This is the subset that we get. Otherwise, exactly. Right? And then we have weak equality, means that 2, 1 is in that set, 1, 1 is not, 1 is yes, but 1, 2 is not, right? Because 1 is not bigger than 2. Okay. So it's a 45-degree line and including below this binary relation. And greater than is also that, but just exclude 1, 1. Is 45-degree line excluding the diagonal. I hope it's clear what we mean by binary relation. Because when I studied this, they define as binary relation, I never understand what's going on. And I look at the math textbook, okay, I got it. Because this is how people define binary relation. And that's how mathematicians define what's equality, what's inequality, those like. And
The question is whether you think it's important. It's up to you. So regardless to understand what is binary relation, you can consider as inequality anyway. So we assume the consumer, assumption 1, we assume the consumer is able to compare. Okay, so that definition is for any bundle X or Y, either X is better than Y or Y better than X or both. Okay, he can't say, he can't decide. Okay, so what is rule out is I can't tell, right? It's either X better than Y, Y better than X, or they're the same, right? So that is the assumption behind. Okay, of course, for those who do behavioral, this need not be the case, right? Sometimes I can't tell, right? Or it depends, right? If it depends, it means that your model is not complete, right? So imagine the situation, right? The standard dialogue would be like this. If your mom and me fall into the water, right? Who you rescue first? What's your choice? You, right? Right? So that is right, but if your mom listen to that, then your mom will not be very happy. So what would be your take? So if your future wife, your girlfriend, or whatever asks you, right? If she or your mom fall into water, which one you should rescue? Your mom, okay, that's good. Okay, but your wife will be very angry anyway. So what you take? Okay. So what about you? Both. Okay. Both is also fine, but both is yeah. Either way. Okay. You say I don't know, then it's not related to it, right? Or there's a perfect answer to this question. If you have a kid, so the answer would be I will save the kid's mom. Then it will be ambiguous, right? Because your mom is also the kid's mom, right? And then your wife is also the kid's mom, right? So that is a answer that never fails. So when the answer never fails, that violate this principle, or it depends, right? If easiest to say no because I can't swim, then it's not complete. Okay. So anyway, so that means that this assumption is actually assumption on one, the consumer or the agent is actually able to make decision. Second, is the description is clear enough, right? You can say it depends, right? If right, if you love your wife, then save your wife, right? If you want to another wife, then you just not probably not, right? So if it depends, is another thing, right? So example would be equal size not complete, right? Because 1, 2 is not in the equal, but 2 is also not. Okay. So there are a lot of things in the world is not complete, but in our model, I think complete is fine because bundle. Okay. And completeness is usually not a big problem. People don't complain about this. I think the people complain about transitivity. Okay. Transitivity is assumption that people are in somewhat consistent. What it means is if X is better than Y, Y is better than Z, you say X better than Z. Okay. So I mean, of course, intransitivity is sometimes not satisfied, right? But I mean, that is a way we assume, right? Why you may see why we need transitivity. Okay, mathematically, it means that we can already reduce the problem of comparing multi-dimensional problem into comparing two pairwise comparison, because we can only pick up any two things in a set and compare it, and once we're done, right? Because any three-way comparison or four-way comparison is the same thing, right? Because we know how these two compare, the other one we follow directly, right? And that make our life easier. All right. So transitivity, I think, is things that if you violate, it's a problem, right? And if market exists, right, there's what we call the Dutch book argument to make money. So in terms of market, you never have this problem, right? Because in the case that you say this is not true, okay, then I can always make money by making this scheme, right? Suppose you start with Z, right? Then I said, let me give you Y, okay, for 1 cent, right? And then you say X better than Y for you, give me $1, I can swap X for you, right? But you say Z better than X, I can swap Z again, right? So I can keep making money by this process. So if you intransitive, as a market, it can't work. Individually, it can be true. But as a market in general, you can't have this intransitive preference. This is what I'm saying. So suppose we start with Z. Okay. I say you say Y better than Z, right? Give me $1. I give you Y. Once you get Y, I tell you, give me $1, give you X. Then you say you like Z better than X, I give you Z, give me $1. You can keep going on this Ponzi scheme. Is that clear? So that's why transitivity would be violated individual level, but not in the market level. Right? So so let's define our consumer. Our consumer will be assumed to be rational if the consumer has a preference that is complete and transitive, right? So it's able to tell you, give two bundle, either one better than the other, right? Or the same, or they can have a transitive means that if X better than Y, Y better than Z, X better than Z. So it's very basic requirement. Okay. Now we'll call this X is at least as good as Y. Okay. And that is the assumption we make. Okay. We can drop this assumption, but this is the fairly basic one. Okay. And sometimes you would see the terminological indifference, which means that the same. Indifference means that X is at least as good as Y and Y at least as good as X. They're indifferent. Why you learn this? Because this is how you learn in the intermediate micro, right? What you learn is called indifference curve, right? Which means that give you two bundle, same to you, right? You map out all the bundle that give you the same utility or the same to you. That's called indifference curve, right? So that's why it's there. And another thing you find called the strict preference. We call this is strictly X is strictly better than Y if X is better than Y, but not other way around. So you say X is super better. It's not exchangeable. Okay. So that is the terminology. I introduced this because this is appear in many textbooks. Okay. And sometimes you will see this 5 different set, right? There's no word set. Okay. So given any bundle, you pick up the bundle that is at least as good, it's no word set. Given any bundle that is no better than that, right? This is given this bundle, any bundle that's really worse. Given a bundle X0, this is the bundle that is better than that, right? And this given the bundle X0, this is indifferent to that. So there's a bunch of sets that is also often you can see in the book. I just put there. When you see the slide with gray color, it means technical. It's not needed for usually not needed for exam, not needed for general application. It included because of field theory. And when you're thinking about building a model, then probably you can look at this, but otherwise you just need to look at this purple thing. Okay, this purple thing is the thing that is a key thing about this class. Okay. So if you look at the Rubinstein textbook, they will tell you that you can assume people have the binary relation, whether you have as good as, right? Or you can assume people preference follow this. Okay, you can define preference by weak preference, or you can assume people start with a strict preference and indifference. Okay, you can say people can tell you X is better than Y, Y is better than X, or X is at least the same as Y. Okay, and this is the alternative way to define the same problem. Okay, I don't want to go too much into this. Okay. Here I have some math here. Probably you will learn it before. Is we define math is I have two numbers in the n space. I would define the standard Euclidean distance is by Pythagoras theorem. It's just the square, the sum, and take the square root again, distance. And we define open ball is the neighborhood at x. We'll be taking anything that is a open ball, is a radius there. Okay, that is the neighborhood. Okay, we define this because we need to define continuity later. But these are the standard thing in the math. I hope you learned that before. Now we probably make some assumptions on preference. Okay, first one is we call monotonicity, which we will need it to prove the existence of utility. Okay, that's very simple. For every bundle, for every element, for every commodity, there's more, then it's better. Okay, more is better. So that means that everything is good, not bad, right? And strictly more for any or some of them, or sorry, for some, sorry, the typo here. For some I, then is strictly better. Okay, I'm sorry for the typo here. For some I, okay. And what does that mean? It means that the indifference curve, right, must be downward sloping. You go to the north east direction, it's always better. Okay, so that is what do you mean by strict monotone. Okay, I think that's okay. It's just how you define commodity, right? You define as good instead of bad, right? So pollution is bad. Then how you define pollution is the absence of pollution, right? That's how the trick is being done. I don't want to talk about that, but if you look at the standard textbook, they will use much weaker condition. It's called not monotonic, but they call no-cool non-satiation, which simply means that for every bundle in the open ball neighborhood of that, there exists a better bundle. Okay, there's no way, nowhere in the commodity space that is you would be very happy, locally satiated. No, there's no point, there's local maximum. Okay, at any point nearby, you can find something good. You can add something to some commodity, subtracting something, always better. Okay, but this is technical. Okay, but why it's important? You rule out big indifference curve. Right, the indifference set must be a line, because there's no way you can find. You can line means that there's something nearby you can find. But it's very technical. I'll just put it there because when you read it, then you will see a lot of textbook they will start with this because it's much weaker assumption than monotonic. Okay, because economists always strive for abstract and more general conclusion, right? So people spend time or spend their lifetime to weaken the assumption. Okay, so what you learn is the result of the work of economists for 50 years. They try to make the conclusion as general as possible. Okay. There's a weaker version. I'm not going to talk about that because technical, I just skip. Okay. The next one is called continuity. Okay. The continuity is a very standard thing. It's just asking people, your preference doesn't swap when the nearby bundles. Okay. So the idea is very simple. Look at the definition. Okay. For any two bundle, X and Y, if X, you like X so much better than Y. Okay. If you give you two X and Y, you like X. Okay. And there must be the case that, okay, you go somewhere nearby X, right? There's some number that you go nearby X, there's a ball there, right? That means that there's something similar to X, change something to X. change them in Y. Okay, only that exists. Okay, still we have X better than Y. Okay, so but we should following. Okay, you before you get married, right? You make it off. One part of the off is say, no matter your partner, who they become sick, become whatever, you still love her, right? So you mean you get married, that means that you love this woman or man compared to others, right? You certainly prefer her or him compared to other people, right? That means that there's some slight changes to her or him, you still be the same. So that's the thing, right? That's continuous, right? You wouldn't say, okay, because now he lost one hair or he earned less money, right? Then you don't like him more. Maybe he earned $1 less, then you don't change, right? Maybe he used to earn $10,000, then you just now he's just earn 1,000, you drop him, it's fine, right? He used to have 10 houses, now he become bankrupt, then it's okay, you can drop, right? But he just make $1 less, it doesn't change, right? The same idea here, right? Doesn't change a lot, right? So, right? For example, right? Some preference not continuous. For example, look at some dating websites. Okay, there's some requirement for women. Or say the man have to be 180, cannot be 1 cm less. Okay, 179 is not good enough, no matter how much he make. Right? Right? No matter how handsome he is, how much money he make, if not 180, no. Right? That is not continuous. Right? You can't find it. There's no way you can convince this is discontinuous. Okay, is that clear? Right? Because when that's the case, that is not continuous. And continuous, I think, is fairly reasonable. But of course, there are many cases it's not continuous. Okay, let me give an example. I don't want to talk about the alternate definition. Okay, but probably you would say this definition is different from the continuity you learn in the math, right? If you learn epsilon delta or continuity, right? And indeed, I mean, you learn continuity in the math is called the convergent sequence, right? And it can be shown that this difference of continuity is same as the continuity we have. But I'm not going to talk about the math. You can check the textbook, okay? But I want to focus your attention on this counterexample of continuity, right? This continuity, okay, is we call as a graphic. It's very common. Again, I cite the example of the Shanghai marriage market. Okay, Shanghai marriage market. When you go there, you will see the preference of the graphic. First, you have the Shanghai Kukou, right? If not Shanghai Kukou, then drops, right? I have a house, right? And the house has to be downtown city center and have to be fully paid, not in mortgage, right? And the third will be have to have a car, right? And the fourth may be the parents have pensions, right? These are, I mean, some laugh, so probably I should take it. If you don't believe that, I think we should check it out. Yes, I don't know if you can see it, but it said man, age, wearer, not 1.8 meters. And undergraduate is can you see? Yeah, that's great, right? And undergraduate is whether work in the local firm or foreign firm, whether you smoke or drink, right? It's a house, right? And then first look at how that's a graphic, right? First look at the man when look at the woman, looking at whether education first, right? whether it's from the urban, whether those things, right? Whether 985, right? And look at whether the family is same, and look at how tall she is, and he is demanding 80, right? 80后, okay? So, and look at this man looking at the woman, okay? Looking at the age and height, look at that, okay? His character, his age, and look at the height and so on and so forth. It's like you can see, take a list item one by one, and usually there's a pecking order to that, right? You have to follow this and this and this, and one thing violated can't work, right? It means that no matter how good you do in the second dimension, if the first dimension fail, you fail. Then it's the common thing is not continuous. You can see this is all that's a graphic, right? Because right, no matter how good you're doing, if you don't have house, then it's off, right? If that's the case, then that's the case, right? Right. I think that's a common preference expressed in the TV show, right? There's a one woman said, I mean, I would rather cry behind a luxury car than happy on a bicycle, right? I mean, 或者好像在宝马后面哭，或者单车上面笑，something like that, right? So that is something like some idea here. Okay, so in here you can see a preference, it's not continuous because look at the first criteria first, and then look at the second criteria, so on and so forth. Okay, let's call it a reference dictionary. How words are ordered in dictionary? Look at the first letter, A first. No matter what the second letter is, Z doesn't matter. And then look at second letter, third and fourth. Okay, that's very common. Okay, and you will say this is one of the research questions you can ask, right? Suppose people have lexicographic preference, how your model changes, right? Because people do have lexicographic preference, right? Say when you look at let's not even look at the marriage market. People, when they choose the college, it's like this, right? People would say, okay, I really don't care about the major, right? People care about the school, right? If they go to top 2, they go to top 2. Even the top 2 is going to do archaeology or not, something that is not making money. That's fine. They're going top 2 is fine, right? And so on and so forth, right? Look at the school first, right? The major becomes second choice. Okay, no matter how good the major is, if it's bottom school, we don't go, right? So that's the same. Okay, and the next thing is what we call the convex preference. I think this is last assumption we need. Okay, and then we can have break. Okay, that last assumption is called the convex preference. Okay, convex preference is a little bit strong concept about if I have bundle X, okay, which is at least as good as Y, is saying that I mix the two. This is called linear combination. Okay, I somehow combine the two. Okay, somehow combining them is better than the worst one. Okay, that is again some continuity idea, right? Because I say X better than Y. Okay, I'm mixing X and Y is still better than Y. Okay, so I think it's fairly fine thing. I mean, just you combine stuff, right? And when you violate this, yes, question. Oh, okay, yeah. Should be lambda should be 0 to 1. Yeah, sorry. Okay, I mean, every year people point out this, I never change it. I should remember this one. So this can be violated when you go to I don't know, go to a canteen, right? Maybe you like very spicy food, right? And this is very spicy food, this is not so spicy food, right? And the combination usually is worse off, right? You also need a non-convex preference, right? Either very spicy or not so spicy. Something in the middle actually is not very desirable, right? So that's why this it violates in certain cases. Okay. And later you will see this preference is necessary to derive the demand function turn out to be. Without that, the demand curve become a very big thing correspondence because it's a become bang condition. So to derive a unique solution, you need this convex one. Okay. But one of the idea is what we call imply, okay, diminishing substitution. Okay, that means that if you have the same thing, okay, the same bundle, increase the quantity, the extra happiness you got is getting less and less. Okay, just like I give you if you get the first $1,000, you'll be very happy. The second $1,000 also very happy. But once you get to the million, get a $1,000 more, not so. Right? There's another thing, right? They call the 7-year itches, right? The first year you get married, maybe you're happy. Second year, maybe happier, fine. I mean, but after 7 years, yeah, become negative probably, right? People get divorced, right? I mean, so the same idea here, right? Just keep going on, but assume you did it true. This is what we have. Okay. So before we have break, then let's review what we have done so far before the break. So we start with the condition where the commodity, which is the environment that the consumer interact, is they choose a n-dimensional vector, okay, and the number represent the quantity, and that is the environment the consumer face. What consumer think? How do they do decision? Right? It's a machine. We define the machine. How the machine come? The machine define is they like preference is that must be complete and transitive. Okay, when they make decision, it must be the case that for anything to bundle, must prefer one over the other, and must be transitive. Okay, there's no cycle, and there will be additional assumption to impose to make our model easy to solve. Okay, these are the basic requirements. And what assumption that make our life easy is to assume monotonic, which actually assuming the environment we're looking at the goods environment, more the better. Okay, this is assuming the environment like this to make our life easier to mathematically. Okay? And the second assumption we make is continuity, where your preference don't change if the bundle change a little bit. Okay, otherwise things become more ugly. Okay, and later you will see this continuity imply your utility function is utility is also continuous. Okay, and that we can do calculus and so on and so forth. Right? If not continuous, then it doesn't work. And we assume convexity. Okay, that means that your utility function, right, is a concave function. Okay, then later you will see that makes utility maximization problem have solution, right? So or have a unique interior solution. Otherwise, you have a corner solution there. So these are assumptions that make our life easy. Okay, you will see as you will see. Okay, so after the break, we will talk about how this assumption from preference transform to utility, and then probably we end up with this maximization problem for today. Okay, let's have a break of 15 minutes and then we'll come back. In the meantime, as I said, I mean, you can fill in and tell me I'm doing too fast or too slow. Maybe I start another one. Okay, let's have a break of 15 minutes and then we come back. Maybe we slowly start by looking at the results. No question. Yep. Okay, so far it's okay. Seems okay. So maybe you can start a little bit to speed a little bit. So here just to try to tell you the connection because the graph we have in different sets, right? So if you put all the bundle that are in different each other, we have in different curve, right? And by writing indifference curve in this way, downward sloping, right? In the line, actually we have a bunch of assumptions there, right? So first is monotone, right? It's a line instead of a fixed indifference set, right? And it's facing the downward sloping, it means that this is better, right? And by writing it in the opposite convex, so this is a convex preference, which means that you combining any two bundle, that is better, right? Or this combine anything worse is also bad, also better, right? So that is by writing in this, actually the assumption when you draw this is already make all those assumptions there. So when you actually learn when you undergrad, intermediate micro is already make all those assumptions. We just spell out the assumption there. Okay, so that is the meaning of learning advanced level microeconomics, is to try to learn everything from scratch. Okay, we start in the beginning, right? When you draw this, when you teach undergrad, right, then this is already built in the assumption there. Okay, so we just make it very specific. Okay, same as all the model you learn in theory, right? We have to specify how the consumer would think in the utility function, later you will see, right? And then how he interact with the environment, how the firm set the prices, and so on and so forth, right? So these are the model. Okay, just trying to show you that this is indifference curve, right? Okay, and if a 2-1 indifference curve, right, will be in this one. Okay, so obviously the purple one doesn't satisfy it's not a convex preference. Why? Because you look at this part, right? It's not convex. So, but this is still the convex. So that's to show you that when you try to draw this, then you have to assume there's something there when you draw it. Okay. Now I guess is once we have the preference, we can start with utility. Okay. And by construction, utility is simply a number assigned to the bundle. Okay. So basically it's a collapse of a multidimensional object into single line, right? Every bundle with a name, give a number. The higher, the better to you. Okay. And when you put number, okay, by construction, number will satisfy completeness and also satisfy transitivity, right? If 3 is better than 2, 2 is better than 1. And 3 must be better than 1, right? So by construction, this is there, right? So that means that just put number there. There's no restriction on what you can put there, right? But this is the a number you want to put. The more preferred one, you put the number there. And as we said, we are collapsing a multi-dimensional objects into single dimension. Then clearly this is not always possible, right? If you learn the problem math, right? Because have to be in the consistent. You can always put number, but the number have to be following this linear order, right? Then has to be some restriction. Okay, and our main goal is to prove the exists. Prove when it's possible to do it. Okay, and you may ask why we don't work with preference. We always start with utility. Okay, in most paper we see utility function. You don't work with preference. The reason is being that when you have utility function, you can do a lot of the math 2 calculus, maximization, use standard technique. If just preference, it's very hard to do math, right? Because you probably require some discrete math to handle the problem. Okay, so that's why we always look at utility function. Okay, and you lose something by looking at utility function. Okay, the first result is very simple. We say it because we want to do some proof to show you how proof looks like. Okay, if you go to econ department, that's how they do. Okay, define utility function, and they will start with this proposition. Okay, suppose you have a utility function representing a preference, and you have some monotonic transformation. Okay, and then this composite function is also represent the same thing. Okay, that means that utility functions are ordinal, not unique. if something represents a preference, a monotonic transformation is also a preference. Look at the example first before we do the proof. Suppose the preference is adding the two bundle to commodity there. You square it and multiply 3 plus 4, also represent the same thing. It's not unique. Okay. And later you will see why this is important, because when we talk about choice under uncertainty, this property fails. It's not the same. Okay. The choice of the utility function it will be crucial. Okay. And what does it mean by regression or empirical? If you think your model satisfies this kind of utility function, when you try to estimate this, how you scale doesn't really matter. Right? When you do regression, that's fine. Okay, now we just do the very simple proof. The definition is x better than y if and only if this can happen. That's definition of utility. Okay? If you impose a monotonic transformation on both sides, right? According to the math you learn in equality, this still holds. Right? No matter it's positive number or negative number, right? This also holds by math. So this u of v, right, is still imply this. Right? This if this satisfies. So that's why this is the right representation. The proof is done. Okay, so that's a 2 lines of proof, but this shows you what you will learn if you go to econ department. Basically, all proof. Okay, but in my class, because in B school, we don't talk about proof that often. Okay, we just focus on why we make those assumptions, what's the purpose, what's the meaning, the implication. But in them, they will just talk about those. That's why they will spend whole semester for the first 4 classes we cover. Okay, because they go over every single proof in detail. Okay, I just cover the main proof, and I think it's crucial. And usually I don't have time, so I just skip. And I also skip the very technical details. I skip the main idea, how proof being done. Okay. Now, the first thing, as I said, is we want to prove the existence of utility function, right? Is it always possible from preference you can go to utility, right? Because we're a very general idea of preference, we just compare bundle. And the question is there always a way that I can assign number to all the bundle meaningfully such that the higher the number, the better the bundle is, right? That is the idea, right? But utility is the higher the number, the better for me. I will choose the bundle that is higher the number, right? So we'll prove it using a graph, but the proof would be saying the following. The preference, which must be complete and transitive, I require that the preference is continuous and strictly monotone. Just to remind you what's continuous. Continuous is our 2 bundle, x is better than y. Somewhere between around x is still better than something about better than y. I can always find something nearby x that is still strictly better than something nearby y. Only exists, not everything, just some I can find something nearby. Okay. And strict monotone means if you have something more, okay, in anything, in any dimension, is always better. Okay. Now we do the proof. Okay. As we said, we focus on the core part of the proof. There's some technical part we just skip. Okay. Now, I'll do this proof. Okay. Look very crazy, but I try to give you an idea how proof being done. Okay. How we do the proof? That's by construction, because we want to show existence, right? So we just show that there's a way to construct such a function, then we're done. Okay. How to do it? Now we consider called a vector E. It's just one unit commodity for each one is E, right? This one is in X, right? Now, this part looks complicated, but let's go slowly. Okay. It means that by monotonicity and contiguity, okay, that means that there exists, okay, for whatever bundle you got, you can always get a multiplier of this E to get to X. Let me show you the graph. What does that mean? Okay, that's very direct. The meaning is X is here. Okay. You have a B, which is called reduced in this dimension. X is better than B, right? Agree? You can go up. A is better than X, right? That is come from monotonicity. Okay. And along this line, right? You go in this direction. From B to A, you're getting increasingly better. That is from what? Monotonicity, right? The more, the better. Okay. And because continuity, right? There must be some point here that will be same as X, right? Otherwise, there will be jump. So that is the main argument. Let me repeat the argument because it's important. Okay. We start from any bundle X, arbitrary X. Okay. We'll map it to the 45-degree line. How we do that? First, go to the left side, B. Okay. X is better than B. I think you agree, right? That's monotonicity. Okay. And A is better than X because A has more of commodity too. Okay. So you walk from B to A, you keep improving, right? And because continuity, there must exist something that is the same as the original X you proposed. So I can always set, no matter what bundle, I can sum something here in the middle. So I can basically reduce a multi-dimensional thing into the line because I can find the indifference thing. Okay. I don't have a multi-dimensional problem. Now I have a map it to the line. So everything there, I can map to the line. Okay. What I need is to find a number on the line. Okay. Every bundle here, I put a number here, then the number is the same as this one. Is that clear what we're doing? So what we're doing is for whatever bundle, we find indifference bundle on the 45-degree line. Okay. Then I reduce the problem of the whole space to the line. Then what remains to be proven is to say each bundle on that line, I have a number. And of course, the number will be increasing in the 45-degree direction. Then I'm done. Okay. Now the first step. The second step is to say, okay, this value is unique because of monotonicity, right? Because you go to the line, it's really better off. So we don't have more than one value is unique. Okay. And indeed, this value is the value we assign to utility U of X. Okay, this is a number there. Now the proof almost done. Okay. Now with the following: X is better than Y if and only if U of X times E, okay, the U of X number of this element is better than U of Y of this E. Is that clear what we're doing? Right? We just care X, right? We map to a number there. This number is called R of X. And Y is mapped to number there is U of Y times E. Okay, basically this one. Okay. And transitivity implies that if this is bigger than this is also better than this one. Right? And then because of 45-degree line, right? This better than this means this number better larger than this number. Okay. Let me show you the graph to continue our argument there. Okay. Our argument was for every bundle, I can find a unique bundle is here. That is from monotonicity and continuity. Okay. Now we want to show you this is actual utility, right? By utility means that if X is better than Y, U of X is better than U of Y, right? And we claim that U of X is basically alpha. How do you do that? This is better than this. And we say this is same as this guy. And this same as this guy. Quadratic line, this higher than this, and done. Because the number satisfy all the completeness, transitivity, everything is done. Is that clear? Is that okay? So, is that clear? Right? That's the proof. Okay. But of course, some of you may still confused about why this works, but maybe you take a moment of thinking and then see if you have any question. Okay, this is a proof. If you don't get it, you can read the book. The book is also the same proof. Okay, the book, you can read the book. They give the same. I just take the proof from this textbook. You can just read that in detail if you still don't fully got it. Okay, but the graphical is like this, the construction. Okay. Now there's some part I didn't prove. Actually, it's more complicated in the proof. Is okay. The question is, so what? I mean, there's a utility, but the utility function can be crazy. Okay. So what actually in the proof, the complicated proof in the book show you that actually can go further, not just existent utility function, but this phenomenon also continuous. So we say, of course, the proof for this part will be way much more beyond the scope of a class. Of course, if you go to the econ department, they'll prove it. Okay, but the proof is not difficult. Actually, just 10 lines of math. Okay, but I'm not going to do it. Okay, but you can check the book. Okay, but the good thing is, as long as you think people have preference of continuous monotone, it's okay to assume continuous utility function. That's it. That make our life easier, right? Because continuous, you can apply a lot of tools, right? Otherwise, you don't know how consumer behave. Is that okay for this kind of proof? I promise you, we don't do a lot of proof, but at least I have given some proof. Otherwise, we are not talking about microeconomic theory, right? Because we still have to give you some idea of the proof. Okay, and I don't prove it, but this idea I think is straightforward. It's saying that if your preference is monotonic, your utility function is also increasing. That is trivial, right? Because the more the better for your preference, right? You prefer the bundle has more, then utilities to assign higher number to those bundle. Okay, that is very trivial. The proof is also very trivial. I'm not going to talk about that because of time. Okay. And one thing is a little bit tricky, but I think you learn all the math class. You learn the quasi-concave, right? So when we have a convex preference, okay, which we have seen before, right? Combining bundle, right? Preserve the strict preference, right? If X is better than Y, if you remember, combining X and Y is better than Y, okay? And this convex preference implies the following: you have a strict quasi-concave utility, okay? That is a if and only if. Okay? That means that if you have any two bundle there, you combine them better than the minimum, the same as what we said, right? Okay. Not going to prove anything there. Just skip. Okay. Up to here. We don't prove anything about differentiability. But if you look at the textbook or look at many textbooks, they are out of the scope. The reason why, because they're actually, I wouldn't say that, but usually they would say we don't have good economic intuition. What do you mean by differentiable preference or not? Right? So that's why we make differentiability just for the sake of convenience, right? I mean, because you learn math, you see continuity and differentiability, there's some gap there, right? But that is a mathematical thing, right? In the real world, we would think that continuous but not differentiable is something doesn't really matter, right? In math, it matters, right? There's a lot of function that's continuous but not differentiable. But from application, I don't see, I mean, that gap there. Maybe there's something, but not for our concern for business school, right? So that would be the idea. Okay. Now we assume, for the sake of convenience, we assume our utility is defensible. Okay. So the first concept you learn in undergrad is also what we call important. It's called marginal utility. Okay. And probably you learn from history of economic thought. They talk about people think in terms of marginal. Okay. They will not think in whole chunk. They think a infinitesimal calculus. They think things bit by bit. Okay, it's a marginal revolution there, but okay, that means that we can apply calculus. That means that people behave like calculus. And in the economic sense, what it means is, okay, if defensible means the marginal utility of commodity means I give you extra unit, very small unit, how much utility you improve. That's low, right? And this is well defined. In our assumption, we assume people can tell this, right? You can say, I give you it's 1 cent. How much utility you go up? Okay, I give you a small bit of apple, so you will be happier. Okay, of course, people are not that sensitive, but we assume people are sensitive enough to give you a small bit. Okay, you can do it. It's approximation. Okay. Okay, I would say defensibility is not an assumption of human behavior, but just for the sake of convenience, right? Although we can't feel things in a very small scale, but we assume in that way that make our life easier as approximation, right? And do remember this mu is a key variable when we derive the solution. Okay. Now, the second concept, as we remember, is before the break, we talk about diminishing marginal utility. Okay, that means that the happiness you get from extra unit of commodity will be reducing. Okay, just I told you, right? Once you get married, the first year will be the most happiest. Your honeymoon, right? Maybe you have an anniversary after that, right? But after 7 years, then you got fall off, right? That's why people celebrate. They get married for 10 years, 30 years, 50 years, because it's very hard to maintain, right? So that means that you drop off, right? And look at this function, log x1 plus log x2, or square root of that. They all have diminishing marginal utility, right? They're getting more units, okay? The marginal utility gets dropped, okay? It's negative, okay? So this is the assumption that we will often make, okay? Now, this is the key variable that we need. It's called the MRS, the marginal rate of substitution, okay? It tells us how people do trade-off, right? Because if you learn economics undergrad, it's basically talk about trade-off, right? Economics is about trade-off, right? Talk about how A trade off the others. Okay. So MRSIJ is defined as MUI over MUJ. Okay. And what does that mean? It means that if you are asked to sacrifice 1 unit of I, okay, how many J you need to get to make you the same happiness? Why? Okay. Definition is if you give up 1 unit of I, how much loss you have is MUI, the numerator. Okay. And if you get 1 unit J, then you will get MUJ, right? The division will give you how many units of J, right? To make you happy, right? So let me repeat. MRSIJ is how many J you need to make you happy to get I, right? Why define this way? Because that's the slope, right? If this is I, this is J, this is slope of the indifference curve. Okay. So this is a proof. This proof if you learn intermediate micro with calculus, this is standard, right? The slope of the indifference curve, if the negative is the marginal substitution. Okay. And the proof is like this. it rely on total differentiation and set something to 0, and I'm not going to do it. Okay. If you need me to do it, let me know. But this is you doing undergrad. Is anyone any problem with this one? Let me know. So is this one okay? Let me do it. Is this okay? Okay. So as a applied class, so I would like to tell you this several preferences that you would often use in practice. Okay, if you try to build your own model for your projects or try to work out some problems, if you want to start with some preference, okay, this is the way you start. Okay, the first one is assume goods are substitute. That means that your indifference curve are downward sloping line. Okay, and the simplest is like this, right? And in this case, is x1 and x2, good one and good two, are same to you. I give you one good one and take away good two, the same. Okay, and that means the MRS is always a constant, right? Because the slope is always constant. Okay, and this is one extreme case. The other extreme case is called perfect complement. Okay, in perfect substitute, they're the same to you, doesn't really matter good and good two. And in perfect complement, which means that the two good cannot be substitutable. Okay, that means that you have to consume them at the same time. Okay, people with this common saying is left shoes and right shoes. You have to have two shoes to be happy, right? One shoe is not going to work. Or maybe some people have to say curry and rice, right? Or Peking duck and beer, I don't know, right? Have to go in the same time, right? So it's have to consume in the same proportion. Okay, and the MRS is infinite. The reason is being that there's no way to substitute, right? Take away one good, you can't really substitute. You need infinite of them. Okay, so that's another one. And the somewhat intermediate case is called Cobb-Douglas, which is often used in the macro. Okay, you just a product of them. Okay, and raised to the power. Okay, and the MRS, which I left it for you for your own exercise to make sure you understand what's going on. You can try to prove this is true. Okay, MRS depend on the ratio of the consumption and the ratio of the power. Okay, and you should try to check it out if you want to understand this. Okay, and that means that the more I you have, right, and this number gets smaller, right? Because the more I you have, then you diminish the modularity, right? You need less unit to be satisfied, right? Remember, diminishing modularity means that the more unit you have, right, the MRS will be getting smaller, right? So that exactly what you present. Okay. And these three preference I recommend is you try to write your model. Don't start with a generic model. Okay, if you're very good at math, that's no problem. Okay, but usually we start with something simple. Okay, then you start with try these three preference and write your model. If something work out, or few of them work out, you can try a more generic preference. Okay, the generic preference we use is, I don't have that here. Maybe I cut it off. Now it's this one. Later you will see. This is the function you often find in all the trade model. It's called the CES. It's instead of product, it's adding raised to the power. And this turned out to include the three examples we have. Okay, but this one is a lot more difficult to solve. So that's why I recommend if you try to solve the model, solve these three, it works out, you go to CS. And you can see a lot of theory, model in contract theory, they assume this perfect substitute or perfect complement or couplet. Okay, you talk about teamwork and contract theory, this is something they do. Because make our life easier, right? When you go to complicated model, okay, you would want to simplify something. Okay. Is that okay for the preference from utility? I hope it's clear how we start from preference, very generic idea, and we get a little bit more focus on utility, which is the number that we can handle, okay, with some assumption there. And now we are going to solve the problem, okay? So now, as we said, this is the environment that the consumer face, okay? And this is the price, okay? Price is the number that positive number, okay? Or positive number that are assigned to each good, okay? We don't allow zero, okay? In the textbook, they allow zero, which means the free good, but we don't allow free good. They are all economic good, so have to be positive price, okay? And we assume the price taker, okay? Which means that the consumer is not Walmart, where he can decide the price. He has no price power, okay? When you do supply chain for the OEM people, then probably you have to modify this, right? Maybe how much you can buy can change the price, right? And everything exogenous, okay? Why we do it? Because make our life easy, okay? You can make more complicated model, but here we assume the environment to the agent is completely exogenous, okay? He can only what can choose is to choose how much to consume, but there's nothing changing the price, okay? If you are from finance, then probably this doesn't hold as well, right? Because with finance, how much you buy actually change the price if you're big enough, right? The more you buy, the price will go up, right? But making the assumption that everything is you can buy as much as you want as long as you pay the price, okay? So that means that we're assuming there's a well-functioning market, right? If not, then things will be different, okay? There are no capacity constraint, right? As well, okay? You can, if this is food, you can put as many food in the stomach as you want, right? Now, here the constraint represented by the budget set, okay, is called the budget Y, is the money you have, okay? So there are two things that the consumer would be subject to is the price and the budget, okay? It's Y, the money he has initially. So we assume that the guy cannot cheat, okay? So that's why how much he buy can no longer no better than Y, okay? There's no credit card in the system, okay? You cannot borrow money and run away, okay? There's no cheating, right? Cannot come generate money Y, okay? So basically, what he can consume is limited by this line in two-dimensional base. If he spend all his money on unique, when good one is Y over P1, right? If you spend all the money on good two is Y over P2. And the line represent the thing that he used up all his money, okay? And we all usually you also allow he don't use up all the money, right? So anything in this triangle is feasible for him. So that is called the feasible thing to do, okay? So basically the consumer problem is within this triangle, he choose a point that make him happy, most happy based on his preference, okay? So that's why we call this is the utility maximization problem here. He would choose a bundle, okay, to maximize utility subject to budget constraint, okay? So that means that in the triangle, you take up one thing that will make him the happiest, okay? The first question is, does this problem always have a solution? And if so, how the solution looks like, okay? So this is a standard question, right? Existence, and if solution exists, is it unique? Okay, And the first question asked is what we call comparative statistics. What happened if we change the market situation? What happened if the budget increase? What happened if prices increases or decreases? Okay, so this is a standard thing. Let me repeat the first three questions we ask when you write down a model like this. First, of course, we have to define very well what the problem is. And second, we ask whether always there's a solution to this problem, whether solution you need, and what happened with the parameter of the model changes. Okay, whereas no matter which you solve the model, always like this, no matter what model you're doing, right? Whether there's a solution, where what is more than one solution or no solution. If there's solution, if environment changes, how your solution changes. Okay. The first is not that difficult, because utility continuous, and this is the feasible set is closed and bound. It's a compact set. It's always x is a maximum. The reason is just use the extreme value theorem. Okay, the proof in the book is half a page. I'm not going to prove it, but the idea is very simple. There's a triangle there. Your utility function is continuous, right? You can always find it's not going anywhere. It's continuous, right? Not out of bound. So you must be able to find something there. Okay, this is a proof. Of course, I'm not going to prove that because it's basically a math problem. Okay. And I often find this kind of proof is always annoying because you say it's economics, and you say, okay, there's a theorem in the math, but anyway, we just follow the standard. We're not going to reinvent the wheel. Okay. So existence and guarantee. The second one is it unique? The uniqueness comes from the idea that if you assume utility is quasi-concave, which means that you combine any two bundle is better than the minimum of two, okay, then it's always unique. Okay, how do you prove that? It's very simple. Okay, let me prove it because the proof is very simple. So because this B is a convex set, so anything in the middle is feasible. Consider you have two solutions, x and y, or a and b. Okay? Two solutions, x1 or x2. They are all the maximum. Okay, but we said that combining the two is really better. But this is still within the feasible set. Okay, but then this is really better. The original assumption of two must be wrong. Let me repeat the argument. Suppose you have two bundles that deliver the maximum utility to you. Okay, but strictly quasi-concave imply combining the two is better than the worst of the two. Okay, any combination of the two is better than worst of two. Okay, so you just combine, and combine you can buy it. Okay, but then it means that this new bundle is better than worst of two. So one of the original two must be wrong. Is that clear? So the idea like this. Let me. I don't have it that, but I can draw it here. So like this, right? This is a feasible set. Okay. And suppose you say there are two bundle, a red bundle that maximize your utility, but also an orange bundle, two distinct bundles that are good to you. Okay. And strictly quasi-concave imply that the following. You draw a line between the two. Okay. This green must be strictly better than either red or orange, because that's what it means. That's the one strictly quasi-concave, right? The combination of the two bundles better than the worst of the two, right? Strictly better. So that means that green is feasible, right? Because the set is a convex set, right? So green is feasible. Then either red or orange must not be maximizing utility. Okay, so that's why it must be the same, not be unique. Okay, do note that I don't involve any monotonicity here, right? I just imply quasi-concave is already done. Okay. That's a simple proof. But as I said, my class, at least for the exam, I'm not asking for proof. Okay. And probably ask what I'm asking for. Later you will see. Okay. But this just gives you the idea. Okay. The next one is called the Wawa's law. Wawa's law is saying that if your utility function is monotone, you use up all your money. The proof is very simple, right? Because if not use up your money, you're monotone, you can still consume the bundle that give you more units, then you're slightly better off. So you must use up all your money. Okay. So you can see that's how economic at advanced level work. So basically bunch of statements. Okay? And then you learn more. Okay? Now here I think it's the last thing we're going to talk about today. Okay. Already we covered 57 slides, so it's a lot already for the first class. Okay. So assume our utility defensible. Okay. Assume we have interior solution. What is the optimal solution looks like? Okay. What we are saying that we don't want to see, we now establish the existence, right? And uniqueness. We look at how a solution looks like of this problem. Okay. The solution to this problem is rather simple. Assuming interior solution, which usually we assume, in business application, a lot of applied paper, we just directly assume interior solution because corner solution is not very interesting, right? If a solution is corner, then why you consider the commodity? The commodities will be excluded from the very beginning from your model. Then you're done, right? So we focus on the case where everything interior. Okay? And in that case, what we have is the key result is MRS is same as the price ratio. Okay, so that's the key result. So we need an economic intuition for this, right? Because you can derive this using Lagrangian, which I tried to show it. But the idea is why this equal to that. We need an explanation. And this is a key part when you write the model, because I think all of you are very good at math. No problem deriving this. But the key point in writing a paper is to explain what you have derived in English. Okay, because no one read your math anyway. Except the referee, right? Or someone want to challenge you, but otherwise no one read your math. From you assume the math, everyone is correct, right? So the main thing is how to explain this one. Why this is right. Do remind yourself that MRS IJ is what? Is if I give up 1 unit I, how many J I need to make me the same happy as before? Okay, let me repeat is if I give up 1 unit of I, how many units of J make me as happy? So means that it's exchange rate in your heart between I and J. Trade-off for you, if give you I, how many J I need to have? Okay. Look at this PRPJ. What's that? It's the market exchange rate. The market would think if you want to buy 1 unit of I, how much you need to pay? It's PI. Right? Okay. And by given 1 unit of PI, how many J you can get? It's PRPJ. It's exchange rate external. Right? The market would think. Right? So what you say is the internal exchange rate and external the same. Why if not you can trade? If that discrepancy, you can always keep trading because the outside world is constant. You can always keep trading to make sure that they're the same. Right? There's no conflict between your mind and the market. So that's the idea. People make decisions such that the internal exchange rate same as the external one. That's optimal. Okay. Graphically, that means that the optimal solution is the, I don't have time to go about that like this. Okay. This is the X and Y, right? And this is all the indifference curve. Okay. This is the budget. Okay. And what is that optimal solution, which is here, when you draw the MRS which is the slope on this one, same as this budget line. Because the budget line, the slope is the price ratio. Okay. And it said the price ratio is a tangency, is a solution. Okay. And that is the one we have. Okay. And in the next class, I'll go a little bit more detail on the little study, give you more idea why the adjustment would work. Okay. And then I will talk about how you solve this in Lagrangian. Okay. And probably ask, what are we asking for this class? It's like this. Okay. Not the proof, but what I do is I'll give you a functional form of the U. Okay. And you try to solve this problem for me. Okay. Not asking you to do any proof. Okay. Just operationalize what we learned. So we have model, I give you utility, give the problem, you solve the solution for me. So like it'll be like this. Something. Okay, something like this. So something you will appear in the exam is like this question. Okay. This question is I have 2 good, take a square root. You want to solve the Lagrangian. Okay, of course. In the exam, probably not 2 good, maybe 3 good or 4 good. And then the utility function may be a little bit weird, but that's what I'm asking. It's operationalize what we learned. Nothing in the proof will be in the exam because we are not a math class. Okay, but I still need to give the math or the proof the background to make sure that you have some understanding what's going on there. Okay, of course you will forget, no problem. But you understand the definition, how it goes. That's the most important, because if I'm not teaching this class, I forget, to be honest, right? But I'm keep teaching many years, then I remember everything, right? But for you, I don't expect you to remember the thing. That's why it's open book. Okay, so I hope I tell you what's going on for the rest of the semester. If you have a question, I'll stay behind to answer it. Have a nice day. I'll see you next week. Yeah. So the video for the class will be uploaded later when the video is ready. So you can check it back when you need it. Okay. See you next week.